I'd like to talk to you about how to use vapor pens to take a lot of sites to the end process very efficiently and without wasting a lot of time on sampling and analysis that you don't have to. And so with that, I'll begin. One of the things I want to discuss with you, if I can get the, hello, let's see. There we go. Typically, the VOC contamination at sites resulted from the mismanagement of large quantities of VOCs in the mid to late 1990s, specifically 1950s to 1960s. There wasn't a lot of regulation back then. We weren't doing recycling. We were producing billions and billions of pounds of solvents each year, and people just didn't know what to do with them. So the ASTM standard was basically take it outside and dump it on the ground. So a lot of people did that, and they ended up, contaminating their site without knowing it. They were killing weeds, and the idea was that it would all evaporate really quickly and wouldn't leave any residuals. Soil gas surveys are important because now you can look for those VOCs still in the subsurface. And if you do a soil gas survey, you don't have to be actually on the contamination, but just close to it. And so you can gain a lot of insight just by doing the detailed soil gas survey to find out where these contamination sources might be. Then you can develop a site-wide strategy if you develop a site-wide strategy for conducting these surveys, it'll be a very prudent thing to do. Combining screening approaches then, using field and analytical data, you improve the site assessment process, resulting in a more timely and cost-effective site closures. And that's what I really want to kind of stress today as I go through my slides. I'll just touch briefly on the tools of the trade that we have invented at VaporPen. There's the typical two of the first two there, the brass and stainless steel are the normal vapor pens that most people are familiar with. We do have the Flex VP, in which the barb comes off so you can make connections to other kinds of equipment, like quick connect valves and swage locks and those kind of things. We also invented the mini pen, which is a small pen that can go in a 2-inch slab and give you a flush mount setting. And a lot of people are kind of switching over to those. They come in two versions, anodized aluminum and stainless steel, and they're really, really easy to use. And so a lot of people are kind of switching to those now. We also have the insert, which is used to collect samples beneath barrier systems. So those usually go in pre-construction, and they're married up to the barrier just like any other plumbing penetration, and allows you to collect, pressure data or samples from beneath the barrier once you get your mitigation system installed. Other things you can do with, we come up with connections all the time, and we come up with other ways to do things, and so we're looking at that all the time. We have a couple of new things coming out this year that everybody should stay tuned and see on our website, and we'll have those up soon. So when you do these evaluations, you start off with vapor pen sampling devices to get your grid set up to collect your samples. There's a lot of field screening tools you can use then when you start to your process. We like to use a multi-gas meter because it gives us oxygen content and PID and LEL. But you can use a frog with vapor pen, and a lot of people do. You take the sample to the frog from the vapor pen, usually in a Tedlar bag. There's also TO15 tubes that you put on top of a vapor pen so that you can run a, concentrate if you're at a site that you're not really sure what the concentrations are and suspect they may be really high. This is a good way to collect a sample for analytical purposes, but not end up ruining a SUMICAN for somebody, and they're pretty cheap to use. Another device, and Mark's going to talk about this next, is for continuous monitoring. We just were with Mark on a site in Ohio just a few weeks ago where we used his equipment there. Very, very useful, and you can collect, a lot of data in just one or 2 days. It's very, very handy. And then, there's the active sampling in SUMICANs, which a lot of people, that's most of what people use these days. They're kind of making the switch over to quick connects now. And so that quick connect to the top of a flex vapor pen, you can kind of make all that connections with just quick connects now. And it's very, very easy and reduces a lot of leaks. And then finally, there's passive sample. We have a way to connect a passive sampler to the bottom of the vapor pen now. And that is has gotten a lot of traction lately. It's basically, we sell the capsule that goes on the bottom of the vapor pen, and Serum has developed the WMSBT passive sampler that goes in the capsule. You install that for a few days to a few weeks, retrieve it, and then send it back to the lab for analysis. So it's nice because you can actually take pressure readings and you can do a grab sample at the same time while you're doing passive sampling. So it affords a lot of flexibility to people. So the approach for your site assessment, start with a gridded approach whenever possible, and do as fine a grid as you can, as you have time for, because you'll learn a lot about a site. The problem is, if you go to a site that's been around in the 50s and 60s, no one there is going to know where they use solvents, how they got rid of them. You know, everybody that was doing that kind of work there during the time when VOCs were really being used for everything are gone. And so, you just have to kind of rely on the expertise of the people in the building at the time. And a lot of times they just don't know where things were used. One of the things you can use is this multi-gas meter. You get VOCs and oxygen and percent LEL. Like I said before, this is the oxygen content on a site. And the nice thing about it is it tends to show you where preferential pathways are. So if you see oxygen content near atmospheric, after you purge the point, and you kind of map this out, you'll see where sewer lines leave the building and water lines enter. And if there's any kind of communication tunnels or service lines, those kind of things, you can see these in the subsurface. Another thing that we really want to enforce on people, or enforce, but just assure people think about, is this preferential pathway. The sewer gas sewer gas is probably the most preferential pathway that we see out there. It's basically just a vapor-filled pipe that runs right to every building. And so if you have contamination in the sewer, it could easily show up in your samples. And this is a study we did of a bunch of points that we'd collected over the years. And we went back and reviewed the chemistry of it, and we decided to include the soil gas indicator, which would be brominated compounds, tetrahydrofuran, a few others. And when we put those on a trilinear plot here with TCE at the top and TCE at the side and sewer gas indicators in the lower left, what we found is that all of our sewer gas plotted where it should, down in that sewer gas dominant area, which was very encouraging for us. But what we also found is that 25% of our indoor air and soil gas samples were actually affected by sewer gas, and we hadn't realized it until then. So it's an important preferential pathway to look at, and keep that in mind. Then eventually, once you do all your field screening, you can then collect a smaller set of samples to run for analysis. And then the field sampling will lead you in that direction. The PID will tell you where the contamination is, and then you can collect a smaller amount of samples for analysis, which helps you to save some money on your budgets and time. There's other things besides summa canisters to do that. There's the bottle vac now is coming more in favor. It has quick connects on it as well, so you can connect right to a vapor pen. Again, there's that TOS 15 tube that allows you to collect samples onto the absorbent and send that for analysis. TOS 17 tube, sorry. So now let's take a look at how you interpret that data once you get it. So here is a site that we did recently. It's a rubber manufacturer, and you can see that the PID readings that we saw from vapor pens put into the sub-slab and in the parking lot actually as well range from 1 to up to 1,500, and so that was quite a range. There was a good bit of range in there that you might not see at most sites, but it was a good bit of VOCs underneath the surfaces, and so we wanted to map that stuff out. And one of the things you need to look at if you're going to start that mapping kind of process is the statistics of that data set. And so when we did a probability plot on the raw PID readings, you can see that they don't really plot along that straight line at all, that they're shifted, and they look like sort of a kind of a log normal plot. When we did take the natural log of all those readings and replot that data, what we found is that it is log normally distributed, which is typical of most contamination sites that are out there. And if you think about it, there's a hot spot and everything kind of bleeds away from the hot spot. And so you're going to come across the hot spots, and then you're going to see most of the places are not very high concentration. And so if you use a log normal distribution, you're probably going to be pretty safe with most of the sites you look at. So we can interpolate this data then in a couple ways on GIS. And here's just the PID reading and heat maps. The straight PID reading gives you a good idea of where the contamination is. But if you take the log normal distribution and apply it and do the heat maps, then you find out that, well, there's a little bit more contamination out there than we probably thought was there. The same thing with kriging. Kriging is very sensitive to the distribution, so it has to be normally distributed. And by taking that log normal distribution, you can see that the kriging before we did the transformation showed a couple of places that looked hot. But again, if you look at it again, you'll see that the contamination is pretty prevalent throughout the site. Now this leads us then to where we would collect some samples. And here's a depiction of the samples we collected for laboratory analysis to move forward with that site. So we didn't collect all the sites, all the points as for analytical, but we collected a handful of them. So we'll look at some case studies. We have a vapor encroachment case study, a brownfield site, a former manufacturing facility, and an active aerospace facility. So let's look at vapor encroachment first. You know, vapor encroachment is part of the phase 1 process. You can collect some samples during vapor encroachment. And so this was a phase 1 on a building in the Cleveland, Ohio area. And when we look back through the historical uses of the property, there was a machine shop there in the 1950s. And so that was a good indicator that we might have some problems there. So we put in some vapor bins. And this is the PID readings plotted out with a heat map on it. And we see that there is some effect out in the parking lot for that. And it may go into the building, but may not. They decided they wanted to collect some indoor air samples paired with sub-slab samples. So we went back in and we collected a few in some areas that looked to be of interest. And we also collected an ambient air sample, which is very important so you can understand what's coming in from the ambient air. And what we found is that this was a good buy for them. You know, that the insides of the building was not affected, but they should be careful out in the parking lot. The next one is a brownfield site. This one is in Western Ohio. It was active in the 1800s and produced a lot of materials. It was mostly heavy manufacturing, but it was time for this site to be sort of torn down and turned into another development of some kind, you know, put it in more useful purposes. And so what their worry was that, you know, they weren't sure what was underneath the slab. So we looked at their petroleum uses and those kind of things that were nearby based on our phase 1 data at the time. And we came up with an approach that would use about 90 vapor pins. And so when we took the PID readings on those, what we found is there was about 5 areas of interest that showed a little bit hotter than most. And so we collected samples there, and those samples came back to show that even though there was effect, it wasn't enough to cause a concern, and they were able to move forward with the demolition of the building and put it back in productive use. Here's a former manufacturing facility in Chicago. This building covers about a city block, and the previous consultant before we got involved had spent about 2 years trying to locate a source of indoor air contamination. So they were ready to move forward with their redevelopment plans and knew they had indoor air concentrations that were exceeding the standards, but they could never find the source of the VOCs. So they were struggling to get a mitigation system that could target the area of interest. The yellow triangles are where they took soil borings, and the green or the blue, the pink dots are groundwater locations. And you can see that their whole process relied on collection of soil and groundwater data to predict an indoor air source. And that's just not a good way to do it. You really can't predict indoor air concentrations from soil concentrations. It's just not practical or possible. It does tell you the kinds of things are there, but it's not a very good predictor of what's going to show up in indoor air. Groundwater is also the same thing. Usually it's not collected in the correct way to be predictive. In this situation, it probably was, but still it didn't help them find out where the source was. So we came in and put in a couple of days, about 90 vapor pins. These were all collected for, we did screening first with a PID, but the client actually wanted a sample from each point. So we took a sample from each point and used a mobile lab method to analyze these by sending them back to the lab. We didn't get a mobile lab at the site, but we sent the little vials that we collected back to the lab for analysis. It was a very effective way to do that. It wasn't very expensive. The PID readings showed that there was a hot source down in the bottom part of the building there. When we got our results back, it matched up very nice with the PCE readings that they had. And they also had some 111 TCA concentrations that were high in that area. So if you look back at where they had done their work, you see they sort of just kind of avoided that whole area. They had one soil sample basically from the area. And the reason that they didn't investigate that area much was it was a reception area in the current building. But if you looked at the history of the site, it was a machine shop in that part of the building. So it's important to tie the history of the site back to what you're doing so you can make these kind of predictions about why things are where they are. Finally, I'll talk about the narrow space facility. This is a facility where the vapor pen was developed. It's in Western Ohio. And the restrictions placed on us, well, I'll back up a little bit. The reason that they needed to understand this was there was a source of groundwater contamination under the building at someplace. They didn't know exactly where, but they wanted to take care of this because if it turns out that the source was in the plating room, which they kind of suspected it might have been, then they were going to have to basically shut down the whole operation. So they asked us to come in at night. We couldn't leave anything behind, and we couldn't visit an area twice. So that led us to scratch our heads on figuring out how are we going to collect a bunch of soil gas samples without doing it more than one event. And so that's why we came up with the vapor pen as a way to quickly seal off the hole and then collect vapor so we could figure out where the source was. So here's our grid. It's 156 points. We collected all the data that we needed within a week. So we were doing about 30 a day. And so that week's worth of work provided a whole bunch of information for us. Here are the sub-slab oxygen readings, and we talked about that earlier. This is showed us where the sanitary sewers were and those kind of things. Very useful. Here's the PID readings, and we see that there was a concentration sort of in the southern middle part of the building, which was unusual. People that were pointing us toward the plating room, which was in the middle of the building, basically. We did the same kind of sampling, sending every sample off for analysis that we did in Chicago. And here's what the PCE readings look like. You see there's a good correlation between the PCE and the PID. And they had some TCE there. Now, they had indicated that they'd never used TCE or never purchased it or anything, so we figured that was probably just a degradation product. But when we used that information then to drill out the site, to look for the contamination in the soil and in the groundwater, what we found was that we found DNAPL at about 15 feet, and the color coding on this diagram is TCE is red and PCE is blue. What we saw was DNAPL TCE, and yet they had no records that they ever used it at the site. So we were very, that really threw up a red flag, like how could that be the case? And so when we looked at and plotted this data on a map of the building outlines through time, what we saw is it matched almost perfectly to the shape of the building in 1950. And so there was obviously nobody from 1950 that was at the building at the time we did our survey that could answer this question. And they had no records from that time that showed that they purchased anything. So it was very telling. You could see how they used TCE for perhaps a short period of time, but they were taking it out in the back and dumping it out the back door and killing weeds and all the things that they were told to do back in the 1950s when they had used solvents. So in summary, some of the takeaways I'd like to have you understand here is that, reliable, meaningful data, if you can get a high quality data set, it really improves your ability to get some insights from your assessment. Using vapor pen with a PID can help to look for contamination sources very efficiently. And you can save a lot of time and money by combining these efforts with other things that you have, like the analytical methods that we all use. And it's suitable for identifying contaminated sources beyond just vapor intrusion risk. So a lot of people use vapor pens for vapor intrusion and kind of associate it with vapor intrusion, but in actuality, it was developed to look for sources, and it still is a very practical way to do that. With that, I thank you for your time and interest in seeing more about the vapor pen. We sell it all over the world. We have a lot of distributors nearby. So if you would like to reach out to us, we'd appreciate it. Or if you need to just contact one of our distributors and get the materials that way. Thank you very much for your time.